VPNs give us the ability to securely connect network devices over untrusted networks. VPNs are made up of security concepts like encryption, hashing, and authentication. There are two types of VPN access: site-to-site and remote access VPNs. Site-to-site VPNs are used to connect multiple networks between remote branch offices and data centers. These tunnels are formed between devices like routers and firewalls that have cryptography abilities. Remote access VPN is for individual remote users. VPN applications and secure web browser sessions can both be used on a mobile device like a phone or laptop to establish remote VPN tunnels. Now we will take a look at how an IPSec tunnel is formed for both types of tunnels. First, the traffic that needs to be encrypted must be defined. This traffic is called interesting traffic. You may only want to send certain traffic over the VPN tunnel. Interesting traffic is defined with an access list on the VPN gateway. Internet Key Exchange is the protocol used to set up security associations in the IPSec protocol suite. IKE is broken up into two phases. In phase 1, hashing, authentication, DH group, lifetime, and encryption are negotiated. Once the phase 1 policies have been negotiated, the peers run the Diffie-Hellman exchange to create shared secret keys. Then the VPN devices will verify their peer identity with authentication, and after these exchanges, a secure phase 1 tunnel is built for future communication. Next, phase 2 parameters like hashing, lifetime, and encryption are negotiated with transform set configurations. Then finally, an IPSec security association is created for the interesting traffic, and data can be encrypted and decrypted between the VPN gateways. VPN tunnels can be set to use two different modes: transport mode and tunnel mode. Let's compare the two. In transport mode, only the payload of the IP packet is usually encrypted or authenticated, and it requires less resource overhead. Tunnel mode is the default mode for Cisco devices. In tunnel mode, the entire IP packet is encrypted and authenticated. It is then encapsulated into a new IP packet with a new IP header. Once VPN tunnels are formed, there are a few different options that you should be aware of for the exam. The first is hairpinning. Hairpinning is when VPN traffic is routed back out the interface on which it was received on. This type of traffic flow is necessary for hub and spoke VPN topologies. Another important VPN option to know is split tunneling. Split tunneling is simply how a remote access VPN defines what is interesting traffic. An ACL is used to specify traffic that should be encrypted or sent in clear text. Remote access VPNs have many options to provide additional control to endpoint devices. Always-on VPN is one advanced feature that forces remote VPN access connections to always be connected to VPN. This allows enterprises to maintain constant control over company-owned assets. The last VPN option that you should know for the exam is NAT traversal. NAT traversal is used when a VPN connection is established through a NAT device. Normally, IKE uses UDP port 500, but with NAT traversal, UDP port 4500 is used. Remote access VPN used to be accomplished primarily with IPSec VPN client applications. This is considered to be the legacy remote VPN access option. Nowadays, SSL VPN is the way to go. One popular method of SSL VPN is clientless. With clientless VPN, no client application needs to be installed on endpoints. A user can simply launch a web browser, type in the VPN URL, and log right in from their browser. Once connected, all traffic is proxied through the VPN gateway through a HTTPS session. Let's hop into the lab and configure a clientless VPN setup on a Cisco ASA with the ASDM management software. When you're deploying a SSL remote VPN solution, the first thing you should do is get a real digital certificate. This is required so that remote VPN users do not get a certificate error when they try to connect. To get a valid certificate on our ASA Firewall for VPN, first we have to create a certificate signing request on the ASA. Once the CSR is created, we then export it and upload it to our certificate authority provider. Then the certificate authority will sign our certificate. We'll then install it back on the firewall, and we will have a trusted certificate to use for our VPN connections. To create our CSR, we go to Remote Access VPN, Certificate Management, and then Identity Certificates, and click the Add button. So we have to give it our FQDN name, our key pair size, and then we're going to save the CSR to a file locally on our PC. So we've successfully exported the CSR. Now we'll take that CSR, upload it to our certificate authorities website, have it signed. You'll want to open up the CSR in a text reader, copy and paste the CSR information onto your certificate authorities website. We'll then download the signed certificate and upload it to our firewall to complete the certificate installation. In addition to installing the signed identity certificate, we also want to install the root certificates of our certificate authority. Usually the root certificates from the provider will come with your identity certificate, or you can download them from their website. Now we have to tell the firewall to use this certificate on our outside interface. So we'll assign the certificate to the outside interface. Now it knows that it can use this certificate for HTTPS connections on the outside interface. Now we're ready to configure our clientless VPN options. So we'll launch the clientless SSL VPN wizard. Makes it really simple to set up your VPN. First, of course, we have to name it. Select the interface that will be active for SSL VPN connections. I always like to give my VPN configurations a group URL so that connections can be made directly to this policy with that URL. And we're just going to use local username and password for this, but of course you could use an external radius server if you wanted to authenticate to an external data store. Then we can make a new group policy for some of our configuration options. And there we go. So we've created our clientless VPN configuration. We have the connection profile and the group policy that was created. If you go into the portal configuration, you can do a lot of customization for the portal that is used by the SSL VPN users. You can customize it, of course, with what the title is and the image, the coloring scheme. You can set which applications are accessible by the VPN client. We can also go into our group policy configuration and set things like the home page that the user will get redirected to, and internal links that can be accessed directly from the VPN portal. Okay, so we'll test our clientless VPN connection. I put the URL to the firewall's VPN interface in my web browser. You can see the web browser trusts the certificate. You can look at the certificate details and see that it was signed by GoDaddy. put our local credentials in. And now we're logged into the SSL VPN portal. You see we have our link to our wireless LAN controller. We have options for SSH and terminal services. I'll go ahead and click on my wireless LAN controller link, test that out. So there you go, we are successfully connected to our internal wireless LAN controller with our HTTPS clientless session through our VPN gateway. You could launch an RDP session directly from the VPN portal. So there you go, we now have a remote desktop session that's being encrypted through our clientless VPN connection. To monitor and troubleshoot our clientless VPN connections, in the ASDM we can go to the Monitoring tab and then go to VPN, change the filter to Clientless SSL VPN, then we see our SSL VPN sessions. We can see the group policy that's applied to the user, the username and their public IP address. We can hit details here to get more information about the connection. In addition to ASDM, we can also go to the command line of the ASA and run the command show VPN session DB and web VPN, and you'll get a command line output of your clientless VPN connections. Next we have Cisco's AnyConnect VPN solution. AnyConnect is pretty amazing. You could spend a whole year playing around with all of the different features that AnyConnect has to offer. It is a client VPN application that can run on laptops and mobile devices. Unlike clientless VPN, data can be transferred directly between endpoints through the encrypted tunnel. So once you're connected, it is truly like the remote endpoint is connected locally to the network. Back in the ASDM, we're going to run the AnyConnect wizard just like we did for the clientless VPN configuration. Give it a name and associate it with an interface, which will of course be our internet-facing interface. AnyConnect can use SSL or IKE version 2, so you have the option here to select which protocols you want to be allowed for this AnyConnect profile. You have to select an AnyConnect image file. The AnyConnect image can be downloaded from the Cisco website and then uploaded to the ASA. We'll just use local credentials here, just like we did in the clientless VPN configuration. But typically you would have an external radius server being used for authentications. You need a DHCP pool for AnyConnect. The remote VPN clients will actually retrieve an IP address from this pool, and those IPs will be used to communicate over the VPN tunnel. We want to make sure that we exempt NAT translations for this traffic, also known as no NAT. And that's it, we've created our AnyConnect configuration. Now let's take a look at what that wizard is actually creating. First we have our connection profile. A good example of parameters you could assign with a connection profile are client address assignment and AAA. Connection profiles are also referred to as tunnel groups when you're in the command line configuration. Next we have group policies. A group policy is a set of user-oriented attribute and value pairs used for the VPN connections. Things like client configuration settings and filters can be applied with group policies. Split tunneling is where we define the traffic that will be sent through the VPN tunnel. You can either tunnel all VPN client traffic through the tunnel or define a split tunnel ACL to only use the tunnel for specific destinations. In this example, with our split tunnel ACL we've created, we're only tunneling traffic that matches 10.0 networks and 10.1 networks. All other traffic will be sent locally onto the user's local LAN. The last AnyConnect configuration options that I want to cover are client profiles. Client profiles are XML files that are stored on the AnyConnect VPN client devices with parameters like the name of the profile as it's shown in the AnyConnect application, always on VPN, and backup VPN gateway destinations. Each time a change is made to these profiles, VPN clients automatically receive any updates each time they connect. Well, now it's time to test our AnyConnect VPN connection. You first need to download the VPN client from the ASA or Cisco's website. I already have it installed on this computer. So here's the AnyConnect VPN application. We'll put in the URL that will connect us to our VPN gateway. And then since I have an alias set up, it gives me a drop down to choose which VPN connection I'd like to use. Of course, we want to use our AnyConnect Lab configuration. Hit OK. And we've established a AnyConnect VPN tunnel to our ASA firewall. If we select this gear icon here, we can see some of the statistics for the VPN connection. We see the address we received via DHCP, the client profile XML file that we downloaded. Route details shows us what is actually included in our split tunnel ACL. These were added on because of a DNS option, but here's the 10.0 and 10.1 networks that we defined in our split tunnel ACL. To monitor and troubleshoot our AnyConnect VPN sessions, we can go to Monitoring, VPN, and just like our clientless VPN connection, we can see our AnyConnect connected clients. And we can do the same in the command line with Show VPN Session DB AnyConnect. One cool feature that can be integrated with AnyConnect VPN is Endpoint Posture Assessment with the AnyConnect Posture module. Endpoint Posture Assessment has the ability to scan an endpoint for things like antivirus and anti-spyware to determine if it's a compliant endpoint or not. If an endpoint does not pass the posture check, then it is denied access to the network or it can be remediated. An example of how you could use posture assessment would be if you only wanted VPN clients to be able to connect if they had up-to-date antivirus, or if you had secret files or registry entries installed on company assets that could be verified during the posture assessment. I happen to have the AnyConnect posture module running on my lab PC, and you can see that it's just layered below the core AnyConnect VPN module. If you click the Advanced Window button and go to System Scan, you can see the compliance information for the endpoint. The policy server is my ICE node, which is doing the posture checking. You can see which security products the endpoint assessment found on my endpoint. The posture assessment check that I have running is if my endpoint has FireAmp running, then it passes the posture check and is allowed to connect to the network with full access. In this video, we will establish a site-to-site VPN tunnel between an ASA and a Cisco CSR router. At Site A on the left, we have the ASA with an inside LAN of 10.1.10.0, and on the right is Site B with a router and local network 10.2.10.0. This tunnel will be configured via the command line on both devices. But then after we get the tunnel up, I'll log into the ASDM on the ASA and the Cisco Configuration Professional GUI management on the CSR so you can see how to use the VPN wizards if you are not comfortable with the command line. In the real world, we would always use the command line, but it can be a lot easier at times from the GUI. Here's our command line script that we're going to use on both the ASA and the router. You can see that there's some syntax differences between configuring it on the ASA versus the router. First, we will define our local and remote networks. This is considered to be our interesting traffic and is the only traffic allowed over the VPN tunnel. Then we configure a NAT rule to exclude translations between our local and remote LAN networks. When the VPN traffic egresses the VPN gateway's outside interface, without the NAT exclusion, traffic may match an existing NAT rule, which can cause issues with VPN tunnels. Next is the Phase 1 policy that defines the type of authentication, encryption, hashing, and DH group that will be used for the Phase 1 tunnel. We then need to create a pre-shared key that will be used for authenticating the VPN peers. On the ASA, the key is applied within a tunnel group, which is the same as a connection profile. Along with the tunnel group, a group policy is also required on the ASA. Next, we will set our transform set parameters for the encryption and hashing types that will be used for Phase 2. To tie everything together, we need to create a crypto map. Crypto maps match interesting traffic ACLs, set our VPN peer public IPs, and define the transform set protocols. To activate the crypto map, it needs to be applied to an interface. This would normally be the outside internet-facing interface. Once the crypto map has been activated, you of course want to make sure that routing is configured throughout the network to send traffic to the firewall and out of the outside interface for traffic to be encrypted in the VPN tunnel. Let's start off with the Site A configuration on the ASA firewall. Okay, I'm in the lab ASA. I'll paste in our VPN script. Looks like it was happy with all of the commands. Now we'll head over to the Site B router and paste in the VPN script for that side. To start the tunnel, we need to send some interesting traffic across our devices. Here's a Site A device on the ASA side. Let's see what its IP address is. So 10.1.10.11. Now let's go and see what the PC's IP address is on the Site B side. The device over on the Site B side has IP address of 10.2.10.12. So we'll see if we can ping that IP from Site A. There you go, so that tells me that our VPN tunnel is working. Let's make sure that we can ping from Site B to Site A. Okay, so we have bidirectional communication. The first verification command I always run on ASAs is show crypto icecamp SA. And that command is going to verify our Phase 1 status. On ASAs, active is the state we want it to be in for a successful Phase 1 tunnel. So we're active for the tunnel going to Site B. We'll run the same command on the Cisco router. The output's a little bit different. On routers, QM idle is the final state of Phase 1, so it's not active like it is on the ASA. So this looks good. This shows me that Phase 1 has been successful. Back in the ASA, to verify Phase 2 and if traffic's actually being encrypted and decrypted across the tunnel, we run the command show crypto IPSec SA. It shows our local and remote network, our VPN peer IP. To truly verify if the tunnel is working correctly, you can tell if packets are being encrypted and decrypted. So this looks perfect. Run the same command on the Cisco router, and we have a similar output. We see our local and remote networks, our remote peer, and our encryption and decryption statistics. Now I'm actually going to delete the tunnels from the command line, and then we're going to configure the same tunnel but from the GUI management applications for the ASA and the router. So remove all of our commands on the ASA, and then we'll do the same thing on the router. Here we are in the ASDM on the ASA. To configure our tunnel from the ASDM, we'll use the VPN wizard for site-to-site tunnels. put in our remote gateway's public IP address, outside interface, and then we can actually call out our objects that we created previously from the command line. Paste in our pre-shared key. We want to exempt this traffic from NAT translation. And then next, as you can see, it's so easy to configure site-to-site tunnels through the ASDM wizards. So this may be the preferred method for a lot of you. Hit finish. Okay, we should be good. Next, we'll use the Cisco Configuration Professional GUI management application on our Cisco router. Here's the Cisco Configuration Professional. It's a software that you can execute on your computer that allows you to manage your Cisco routers with a GUI application. So I've already added our lab router as a device. If you click on the configure button, you can see the different types of configurations that you can push to the router from the Configuration Professional. It's actually really cool. You can back up your configurations from here, upload files for software upgrades if you'd like. Okay, so now we'll configure our site-to-site VPN tunnel with the Configuration Professional wizard. We go to Configure, Security, VPN, and then Site-to-Site VPN. Launch the selected task. You can go through the quick setup wizard, but we're going to use the step-by-step wizard so we have the ability to customize some of the configuration. G1 is our outside interface. Put in our peer IP address and pre-shared key. By default, it has this 3DES policy. We're going to add a new one to match the security on the ASA side. We'll select that proposal and hit next. We also want to make a custom transform set. We'll select add. Hit OK. And next. Now we have to define our local and remote networks. Site B is 10.2.10.0 with a /24 mask, and Site A is 10.1.10.0/24. So that's it. We've created our tunnel with the Cisco Configuration Professional. Click Finish and deliver the configuration to the router. Okay, so we should be in business. We'll go to our Site A PC and generate some interesting traffic to start the tunnel. And we're getting replies, so that's good news. Back on the ASA, if you go to Monitoring and Sessions under VPN Statistics, we can see the status of our tunnel. Up here you can see we have one active site-to-site VPN tunnel. Back on the router, we can go to Monitor IPSec Tunnels, and we get some of our Phase 2 statistics and a nice green icon if the tunnel is up.